Great. So, very welcome to this, I think, quite special webinar that we are having today about a new product, the AirGradient Go, that we are launching actually today. And I know that a lot of people are excited about it internally with AirGradient, as well as from the community that have been involved in actually the development, the co-design of this unit. And I want to go share my screen right now. I want to go a little bit into like the first a bit like the details of the or why we actually started developing this monitor, like our the use cases that we have in mind, also a bit the limitations that we are facing. Then a bit of what are the key features of this unit, and then diving into the scientific part, like how we selected certain sensors. And then in the end, we will also talk about availability and pricing. And I'm joined with obviously my team, and I think especially Ethan and Natalie, they will keep an eye on the chat. So feel free to ask questions in the chat, as well as at the end, we can have an open Q&A about this new unit. So here you can already see a picture. We at the moment we have pre-production enclosures. They are more transparent, so this is slightly edited, but you will see that in a second. Good. So why did we start developing the AirGradient Go? And actually, this goes back to a very long time, I would say, and right to the start of AirGradient. And I think many of you know that we started as a volunteer project out of my children's school during the so-called burning season in northern Thailand, which is happening actually right now again. And at that time, I was parents president at the school. And there was a lot of anxiety among parents, like, are their children actually safe at school or safe at home? Do the teachers switch on the air purifiers or not? And a lot of the parents and also the students came into with, some portable PM meters and trying to make sense of the situation. And already then we felt, like my co-founder and me, like felt, hey, it would actually be nice to have something like a device you can put on the backpack of your child. And then it would just track basically the exposure during the time after like leaving home, and then on the way to school, in the school, and basically back. So it was already at that time in our mind, but I think it was also, we recognize it's a pretty complex product. So we first said, okay, let's start with something a bit simpler, like we started with the indoor monitoring, I think many of you know. And then we ventured into stationary outdoor ones, and now I think we felt ready to develop this part. So what you can see here, okay, mute, please mute yourself, everybody, is that, that's like 6 years ago where we started with the alcohol monitoring, and we built like purification equipment. And then we looked actually out what are certain monitors that are actually available in the market, and what we actually wanted, we actually didn't think it's that special, but it's actually not existing. So we were looking for a portable monitor that's actually weatherproof, and surprisingly, not all of them are. So you can't really, go through a rain shower or something like this. Then I think pretty much any of the portable monitors does not have a display on the unit. So you always need to like have your mobile phone next to it to really see like what are actually the air quality numbers. We were looking for something that's suitable for indoors and outdoors, and I think many of you know indoors in many parts of the world you might be more concerned about CO2, and outdoors it's often more about pollution like PM 2.5, for example. So a lot of the portable monitors, they're either CO2 focused or PM, and only very, very few actually are doing both. Um, and then obviously when it comes to portable, you might want to put it on a table or hang it on a bag, or if you want to have it permanently somewhere, you might want to mount it on a wall. So these kind of placement or mounting options we felt were quite limited. Some of the units existing have a longer battery life, some are very short. Um, yeah, we felt it was like this, we had like 4 or 5 important points. It was always like, yeah, maybe an existing unit addresses 2 of them, but nobody really tried to address all of them. And we felt these are all kind of very important things that a portable monitor should have. So what else led us to really, like in earnest, basically developing this? And I think many of you know that we work with many, many communities. I think some of them are also in this call here about really, around advocacy for cleaner air. And the the monitor, especially the outdoor monitors that we have, do a great job. They basically give data on the map, or we share it with OpenAQ, and this data can be used for making a case for like cleaner air. But we think a portable device, especially with a display, could be really great for like community advocacy. So something that you can have at events, and what we see here on the picture is Urban Better. It's a group that has a couple of hubs in Africa, and they do runs across cities, and they measure the air quality at the same time, and then really use that events to advocate for clean air. So when we saw or when we started working with communities like this, we felt, hey, like having a more portable device could actually be really, really strong for community advocacy, in addition to what I mentioned earlier, like, better knowing what's your personal exposure of your children, for example. And what I think the whole thing really triggered it was when back in I think September, October last year, I was on a conference together with my colleague Ethan in Lagos in Nigeria. And we also took the time to go with a researcher from the University of Lagos into a slum where actually the women mostly were like smoking fish that the man took from the sea. And the children there especially were really permanently basically in smoke. And it was something that really like made us think like how much a case could be done if we could really track basically the exposure from these people in that area, and really quantify it, and then use that information to hopefully like go to decision makers or the local groups there and make a case for improvements. So this was the trigger, and then on the way back in the plane, Ethan and I basically sketched out, okay, like what do we want actually this portable monitor to be? So a little bit of a summary. So I think what we target with that device is it's really about health conscious individuals that want to track their personal air pollution in their daily life. See, okay, where do I have certain hotspots? Maybe on my way to work. If let's say you cycle to work, you might detect, hey, there's a construction site that I pass that has, a lot of dust, and then you can maybe adjust your route. We are in touch with many, many scientists and researchers from our existing work. So often they want to have, like exposure studies, see like how are maybe certain segments of the population exposed to air quality. It could be something like delivery workers, for example, in cities, and see what do they actually breathe. And often that's where stationary and reference grade instruments fall short, because they are too far away from the emissions, basically. I mentioned community and citizen science groups. I think it's a great tool to really advocate for cleaner air and giving them a tool that just makes the air pollution a lot more transparent. Same basically for educators and students, because it's a great device just to make experiments. You can take the device and maybe get it close to just a fire or a vehicle that exhaust basically, and see, hey, like, is it only PM, or is there also CO2 coming out, and so on. So yeah, that's roughly like the the groups that we feel can really benefit from that device. Now, little bit diving in, what does it actually have? So we measure PM 2.5, and I come to the specific sensors in a second. CO2, atmospheric pressure. This is actually important to like calibrate CO2 sensors. If you give atmospheric pressure, you can have them a bit more accurate. We put in a VOC sensor that's probably more useful for certain spikes and not so much for the absolute levels of VOCs. Then obviously temperature and humidity. Maybe something important here, because I will not cover that later on. Measuring temperature and humidity is surprisingly one of the most difficult things in an air quality monitoring that we already discovered with our outdoor unit, where we have limited ventilation. And it will also be challenging for a portable one. We have the temperature sensor on a probe sticking out at the bottom, so it's a bit more exposed to air. But if you need accurate ambient temperature, this will be a tricky device. What's the features? Coming back to one of the first slides, yeah, we really wanted a display on it. This has an e-ink. I think it's a 2.1-inch display, which is great because it's very easy to read outdoors. Specifically, it has a very low energy consumption. GPS is on board. We have also onboard storage, I think 32 or 64 MB. So you can actually save a lot of the air quality data directly on the device. It has an accelerometer. The main use case is here that if you want to have a very long battery life, you might want to have a dynamic frequency. So if the device is on the move, you most likely have more variability in the air quality than if it's stationary in the in your home or in your office. Then you probably need a less frequent measurement cycle, and this gives you really like just a smart way to extend battery life, basically. I think what's really important also to point out, I think many of you use our device with Home Assistant, so the firmware is, I mean, currently under development still. It will be based on the same firmware we have on our other devices, which are compatible to Home Assistant. I think one thing we have to figure out a little bit with Home Assistant, if you can actually use the map, which I need to check with them. But there will definitely be an interface that you can integrate it into Home Assistant. One more thing which is designed into this product from the get-go is obviously if you have a GPS in a device, privacy becomes much more of an issue. So we see the device itself as a standalone device, so that with the onboard storage, you can then save your routes with the GPS coordinates that you can potentially switch on and off on the device. And then we're gonna have, I think we see this here, our current apps for iOS and Android will then be able to actually link via Bluetooth to the monitor, and then you can basically download a route to your phone. Okay. And then the first thing is it will stay on your phone. So the apps have a database and the data is on your phone. And then as a basically third level of kind of saving the data, you can then share the data or back it up to our server if you like. So there's really like this idea that you keep the data as long as you want on your own device, either the monitor itself or your phone. But obviously, if we saw before this use case with the communities, obviously they want to share the data. They want to advocate in public about, the air pollution on certain routes. So I think there will be both like use cases where the data, should be private to people, but at the same time, there will be, I think, a lot of use cases where people actually want to share the data. But with this privacy first approach, I think we can cover that very well in general, yeah. But here you can see a bit of a preview. These like features are not yet publicly available on the map, AirGradient map app that you can download, but it will probably look very similar to here. So you can see the streaming data basically on your phone. So for example, if you have the device tagged on your backpack and you don't see the display, you could potentially then see the same data on your phone, and then you can also see like how it's basically tracking the route and how is the air quality changing on depending where you are.
Yo lo voy a hacer ya. Como te digo, estoy ahorita
Um, so let's go on. Oh yeah, that's I think people who know us know we are open source hardware proponents, and all our existing monitors are open source hardware. So no exception for the AirGradient Go. So this will also be open source hardware. Firmware will be in GitHub. You can download and the KiCad files and so on. I think once we have the final version are available, we're gonna make these available, and most likely under the same license CC BY SA that we have the other monitors as well. Great. So sensor selection. I think now it will get really interesting. So a portable device actually makes the sensor selection a lot more challenging. So typically, or in the past, when we had our stationary indoor outdoor monitors, we basically looked at, okay, like which sensor, let's say PM module, really gives us, accurate results and maybe correlates well with, like a reference station. But when it comes to like a portable monitor, I think there are two things that we need to look in addition to, let's say, the general accuracy. And one is obviously we need this monitor to respond a lot faster than a stationary monitor. So just imagine you have the monitor, like let's say on your bicycle, and you just go through a cloud of smoke because somebody is maybe having their barbecue grill on the roadside. You actually want to, see that spike. So basically every breath you take, literally you want the monitor to be able to detect. So we need a very, very fast response from the monitor. And then the portable monitor will always move basically. So there will be a lot of transitions in temperature. There might be vibrations if it's on a bicycle or motorbike. There might be very high airflows that could potentially impact the measurements that you don't have on a stationary. So we were thinking a little bit, how can we actually test this and how can we make science fun again, I would say. Then I got the idea. So my kids went to study both. And there was still a box in one of the kids' rooms, and it had an old like remote control car that we built like I think more than 10 years ago. So we felt, hey, this could be a great way to actually test these monitors. So what you see here is basically the test track. So we 3D printed the enclosures. At that time, we didn't have the pre-production units. You see four of the AirGradient Go's mounted on the roof. We have them with 4 different PM sensors in that case. And then we did, hopefully this works here. Let's see. Yeah, we have also this first shooter camera, basically. Let's see if I can. Yeah, let's just go very quickly. I hope you can still hear me. So we had the first tunnel with smoke, and now we go through a tunnel with clean air. And you can see so we try to really simulate different levels of PM. Here's Bertie, one of our hardware engineers who got really good in driving the remote control car basically through the tunnels. And I was really surprised about the results. So let's dive into this. So what you see here is first the PM sensor testing. So we looked at 4 different sensors, and one of them, the cubic PM 2012, gave us actually 2 different values based on different calibrations. So what we see here is basically the tunnel with the dirty air where we burned incense smoke. So you had an ambient level of, I think it was around 30 micrograms. All the monitors very similar. And then the remote control car was basically driving into this tunnel and then out again. And what's interesting is that we see quite differences in how the sensors respond. Even so, outside the tunnel, they were very, very similar. So what we see here is that and I think 2 things are striking mostly, like the blue one, which is the Sensirion SPS 30, was actually the quickest to react. Okay. And the green one, which was the Blantower PMS A003, was the slowest one. And I think what's interesting here on the green one, it seems that this sensor is actually doing a moving average. So it's not immediately showing you like the kind of real-time exposure, but just kind of, yeah, like making a moving average. And the other ones, the cubic ones in between, didn't have the moving average, but they were slightly slower in responding it. I don't think we can really make a judgment on the actual levels with the micrograms because I think there could be different like plumes of smoke, but just the reaction time I think is quite interesting here. And then we looked at speed, okay? And here what we did was we didn't run the remote controlled car through any of the tunnels. What we did was we stopped, not run at all, and then we run as fast as possible, and then we stopped again, and then we just ran the car as fast as possible. Okay. And what we obviously want in that case, because we want to measure ambient air pollution, we don't want to see much changes. And what's interesting here is that we can see 2 of the sensors didn't react to the speed of the car, the green one and the blue one, which is the blue one against the Sensirion SPS 30, which was stable, and the green one is the Blantower in that case that had the moving average in the previous experiment. But the cubic ones were highly impacted by the speed of the car. So that, I think, gave us a very clear winner in a way, the SPS 30 from Sensirion, where we feel, okay, this is the fastest reacting sensor and also the least impacted by the speed of the car. Great. So let's move on to CO2 testing. So what we did for this test, because the CO2 sensors in general are smaller than the PM sensor, so we were actually able to put 3 CO2 sensors onto the main board of the AirGradient Go, which you see on the left. So we looked at 3 sensors, interestingly, with 3 completely different sensing technologies. So we have the SenseAir S12, which you see on the right-hand side. It's a brand new optical NDIR sensor from SenseAir. We use SenseAir for our existing models. We are quite happy with it. So it just came out pretty much when when we did that start, so we got one test unit from them that we put in. And yeah, it's an optical NDR sensor, so it measures the CO2 levels directly. Then we have the SED 4X. I think we use the 43 in that case, which is a photoacoustic CO2 sensor. So basically, it uses um, a microphone. So like the CO2 molecules are put into a vibration, and then microphones basically can hear the hum of the molecules, and with that can then estimate the CO2 levels. And then also from Sensirion, the STCC4, which is a thermoconductivity sensor, which basically uses the conductivity of temperature to make or the conductivity of CO2 to make an estimation of the CO2 layers. It's a very, very small sensor you can see here. And it was great to have them all in one device, because that's allowed us to really measure exactly the same CO2 levels, and in a very handy way. So let's have a look at the results. So first, on the, let's say, more meta level, we can see the three sensors with the three different colors. And what we did here was, over, I think, an hour roughly, I took them with me. Basically, first we started measuring in a restaurant, then we stepped outside, then we went home into the car, stepped outside, and then went into our house. So let's say on a very meta level, they all seem to track CO2 reasonably well. But then we looked into more details, and then that's where it got more interesting. So here is basically a zoom in when we were just kind of leaving the restaurant. So on the left-hand side, we were still in the restaurant. On the right-hand side, we were in the car, and we didn't turn on the fresh air circulation, so it was recirculating air, and then the CO2 levels go up quite quickly. So in between was basically where we were just walking from the restaurant to the car. And I think what's really interesting here is that we can see that the optical NDIR from the sensor S12 really was the one that reacted the fastest, was reaching actually ambient CO2 levels of around 420 or 30 ppm, which the STCC4, the thermoconductivity sensor, never reached. So it went a little bit down, but never really to the ambient levels. And we can see on the SED 43 that it kind of just reached the ambient levels, or maybe even too low, just before we went into the car, but with not a very smooth curve. So I would have expected a much smoother curve, because we just stepped outside. It could have taken a little bit of time until the ambient CO2 levels really reach or penetrate the enclosure completely. But obviously, a step like this isn't probably what we want to see. So for us, also on the CO2 side, it was quite clear that we prefer the S12. And then the problem was that this is a brand new sensor, so the availability was first given us as at end of the year, which obviously we want to launch this product a lot earlier. And I was very happy to talk to Sensair, and we will get a big amount of these units in May. So with that decision, we said, okay, we can wait a little bit longer and make sure we have the best possible CO2
Jokesha.
in that device. Great. So let's talk a little bit more, not only about sensors. So for us, I think many of you who received our sensors know that we do a very environmental friendly packaging. And we felt for this kind of portable unit, it would actually be nice if we deliver it together with a small bag. And then the bag, the first thing we said, well, we have to be careful. If people put this monitor into a bag, obviously it will impact the air quality measurements. So we spent quite some time to design that bag so that it has an opening at the bottom, and we tried different versions of it. And I want to keep this a little bit short because we want to go into a Q&A later. So the version on the right-hand side had basically no impact on the air quality measurements, whereas A and B were actually drastically reducing the PM values with this. What's nice also, this is a locally produced bag here in northern Thailand using local materials. So we also try to support the local businesses here. So this will be part of the AirGradient Go, and it will also help us actually making it easier to transport because we put it into that bag and then we can ship it off in our carton box as usual. Great. So now I think some of you might have seen on LinkedIn or maybe here in Asia. So this week we were at the Better Air Quality Conference in Bangkok, and we did a so-called walkability tour actually just yesterday. So we took our devices with a group of people. So this was our booth here at the conference, and we had, I think, 3 or 4 teams or groups with the AirGradient Go, taking it for a walk from the conference center to a restaurant, taking different routes, and we live broadcasted actually the AirGradient data and the location on a map here at our booth. And this was just a picture here. You might wonder what is the green stuff here, and there was actually the conference center had really good air quality inside. And because the GPS was obviously very limited, because you don't get much satellite fixes, that's why I didn't really get the location 100% right. So a bit of impressions here from the tour. So I think people were really, really interested. And the nice thing with Bangkok is actually that there are quite a lot of pollution hotspots everywhere in the city. And I want to show two, which was interesting. So you often see these street kitchens, I think we call it, where they cook whatever you want to eat, basically. So you see on the left-hand side, we had actually two monitors like identifying the same hotspot. So these were 2 independent data points. They not communicate with each other. So both really picked up that smoke basically from that street kitchen. And by the way, what was really interesting today, I was in a presentation about source apportionment, where a researcher looked at what's actually causing PM 2.5 in the city. And there's actually quite a big amount coming from cooking. So I didn't really expect this. And that's even true for like Europe or North America. So let's go on. And another area that people walk by, and interestingly here, I think it was mostly picked up only by one monitor. Might have been due to maybe on which street side you are walking, or maybe there was a wind blow, or I don't know. But this was a construction site, so with potentially a lot of dust that got picked up here. Yeah, so all in all, the tour I think was quite successful. We got a lot of interest. I think it was also great for the participants to really see the display of the monitor, that you can really immediately see, okay, there's some elevated PM or CO2 if you're inside. Great. So to go nearly at the end of the presentation, and we can open the floor for Q&A. I guess all of you are really curious about pricing and availability, and I want to just show this right now. So a lot of you might know there, I think, probably 2 or 3 competing products. They're around $250 USD priced, so we want to be slightly lower. We're gonna put an introductory price of USD 199. And then especially for this community here, and because we are extremely thankful for all the support we get from you, there will also be I think 1 week valid coupon code, which gives an additional 10% off, which is AirGradient Go exclamation mark. It should be available now from now on in our online shop. And I mentioned the delivery time, so we really want the sensor S12 NDIR, optical NDIR CO2 sensor, because we think this is just the best possible sensor. So this will be, yeah, like we got promised to get this in May. We also have to, um, yeah, kind of just get the automated production ready, the pick and place machines need to be programmed and all these kind of things. We also, maybe let me point out this again. So this is the pre-production enclosure. So the mold is nearly finished, but it doesn't have a texture yet. So all this area outside the display area will be, like a milky, semi-transparent polycarbonate enclosure. By the way, the enclosure will be UV resistant, and polycarbonate is extremely tough and hard plastic. So this should be quite, yeah, like resistant to any impacts that it might get. Great. So I think that was my last slide. So I will just stop sharing here, and then I'm not sure even if there's some questions already in the chat, then we can maybe go on this, or if you have anybody can also raise their hand and ask the question here. Ethan, do you have anything?
Yes, I've been trying to answer the questions that I can as they come up, but I've also noted down a few. So I think you briefly touched on it earlier, but Aaron was asking about Home Assistant integration and potentially like a timeline on that.
No, I don't really have. I mean, Home Assistant is really important for us, and the integration. I think that the basic integration should not be very complicated, because I think you know that our indoor and outdoor monitors, they pretty much use the same firmware, the same integration, and we have very similar air quality parameters. So for you just want to see the data in Home Assistant, I think that should come very early. I think what's the more tricky part is Home Assistant also has this map, and I'm actually not sure like to what extent we can like transfer routes and display them inside Home Assistant. So this is something that might take a longer while. But we would also be really interested, with the Home Assistant is open source, our firmware is open source, if people want to step forward and help us developing this integration, it's something that would be very, very welcome. Yeah, I hope that answers that. Any more, Stephen?
Cool, thank you. Carlos asked if the portable device will have the same API at monitors.
Yes, probably something additional as well. So what we have at the moment for our like prototypes is that we have a new entity called routes, because what you might want to do is kind of like, let's say you go for a hike and you want to record the air quality during your hike. You might just want to switch it off, and then it starts recording the GPS coordinates and the air quality. And obviously you want to have these different routes, separately, basically. So there will be an additional API endpoint routes that gives you then a certain ID, and then you can pull just the data for that particular route, and then could, for example, show it on a map. Yeah, but in general, the API will be quite similar, but then we will also have some additional parameters, like for example, the pressure. So far, none of our sensors has air pressure. Obviously, the GPS coordinates, there might be something with altitude as well. So yeah, but the general structure of the API will be very similar.
Okay, there are quite a few questions. I will just try and combine the ones that are similar to save on time. So we had a few questions about whether we considered other sensors, namely things like nitrogen dioxide, methane, etc. So yeah,
Yeah.
could you please explain if we did consider those?
Not yet. I would say, like, we know from our AirGradient Open Air Max outdoor monitor that how difficult it is actually to accurately measure like NO2, for example. And we know it has a huge influence cross sensitivity with temperature. So the calibration will be extremely difficult. On the other hand, depending on the use case of this portable monitors, you might just want to see certain spikes in NO2. And I think CO might actually be quite interesting for this because a lot of countries still, especially in the global south, are still in very incomplete combustion. And CO2 levels are easier, for example, to measure with these sensors than NO2. So we have a little bit of space left, which is the good news in the enclosure. And I could very well imagine that we're going to add some, but it will definitely take a little bit more time. And also, we really need to discuss then with the people that need this sensor, like what's their use case and manage the expectations because the electrochemical sensors are just much more difficult to get accurate, whereas with PM and CO2, we have worked with a very long time, and we have a really good understanding on, okay, this is something we can give to pretty much anybody and they get reasonable good results.
Okay. A lot of people are also curious about the battery life. So would you mind elaborating
Yeah.
on that?
Good question. So up to now, we just wanted to test, all the hardware and that everything works. And so we didn't really optimize for battery life yet, but we did calculations, and I mentioned also earlier we have the accelerometer. So the aim is to have the battery between 2000 and 2500 milliampere hours in there, and we believe if you go for more dynamic frequency, we want to get up to a week, potentially even more on that. If you want to go for, let's say, 1 second frequencies of measurements, and that's what we are testing right now, I think you have around 10 hours of battery life. So if you, for example, do these community activities or, a marathon or want to put it on your bicycle and measure something, you have for sure this range of timings there, basically.
Another popular question is about the kit. So do we have a kit or will we have a kit available for this
Yeah,
device?
I actually forgot to mention that in the presentation. I mean, it's open source hardware. It's easy to repair, but it's a much more complex product also from the mechanical and hardware side than our existing monitors. And one thing is, for example, some of you might know like these displays, like the e-ink displays, they have this kind of flexible cable, or how you call this, and it can break quite easily. I think some of you might know when they have repaired their monitors from their notebooks and stuff like this. So we have to find a way that we can make sure that people not accidentally break something when they build it, and this is much more difficult than with our existing kits. So at the moment, for us, the purpose is to make this monitor as robust as possible. And obviously, a portable monitor can also more easily fall down, and so we have to make sure it's not breaking too quickly. And once we have this, we will look and like, can we have a kit that's people can really build without a high risk of breaking things. But it's definitely something we want to support. But it's just we need to also make sure that people are not getting disappointed because they accidentally break something.
And can the monitor be used as a stationary outdoor monitor if needed, and will this harm the battery life?
I'm not sure if it would harm the battery life. I need to probably check this, but you can actually remove the battery if you plug in the power. And not sure if I have actually one. I have one here. There are two holes at the, okay, this is difficult to see. Okay, anyway, I can select. So there are two holes on the enclosure that you can then mount it on a wall. And then just plug in a USB-C cable and you can run it continuously. And same for indoor. So this is really also something that, if people say, hey, like I like this design a little bit more than maybe the AirGradient one, that we can also use it stationary. One more thing I forgot to mention actually in the presentation. So we use the ESP32C5. And that's a brand new chip, which is interesting because of a couple of things. First, it has Bluetooth and Wi-Fi, and we will support both. So you can really run this also stationary with Wi-Fi. You don't need Bluetooth. You can send the data directly to Home Assistant or the AirGradient dashboard or whatever you want. But then also the C5 actually supports 5 gigahertz Wi-Fi, which is the first ESP microcontroller that does that. And that might be interesting for a couple of people. And then I think it's also Zigbee and Thread. We don't support that with the software yet, but for us, it's also a jump in, just having a more modern MCU that probably we're going to integrate later on when we upgrade the other products as well.
Well, thank you. And will there be any kind of alert system, for example, if a certain pollutant crosses a set threshold?
Okay, good. I get all the questions now that I forgot to mention in the presentation. So the unit also has actually a couple of RGB LEDs. We are still kind of figuring out what's the best position, especially when we have this more milky enclosure. But this one is something that, like you can then, like if the monitor detects like a pollution hotspot, it could just glow in different colors, or you can use the US EPA purple color, whatever you want. We are also considering, but this is not confirmed yet, if we can put in a small buzzer with a sound. I think this might be quite interesting, but we have to test this a little bit more because this came in quite late, so I can't make promises here. We have to see a little bit how loud they are, if we can still integrate them. Our current prototypes don't have them, but I think this might be quite a nice thing to have. Yes, so I think there should be alerts, like kind of physical alerts from the device. I think this would be really helpful.
Another quite common question is regarding the data storage and the measurement intervals. So could you please explain those a little bit more?
You mean like how long we can store data?
Yes, and whether the intervals are adjustable.
Yeah. So intervals are already adjustable even with our like beta firmware testing software. So at the moment we can have like 1 hertz is the highest frequency. I think that's also the maximum probably. I think some of these sensor modules don't give you a higher frequency. And then you basically have everything, like 10 seconds, 1 minute, 5 minutes, 15 minutes, 1 hour potentially. So yes, this will be definitely configurable. And then so I think we either have 32 or 64 MB flash chip on the PCB. So it will not be an SD card. It will really be like a flash chip because I think SD cards could have mounting issues at some point. And that's a lot of space for data. I don't have it in my head, but I think we can save weeks of data if I'm not mistaken. And maybe Sam can put something in the chat if he has calculators. But obviously, it also depends on how much parameters we want to save. Do we want to save GPS coordinates or not, and so on. But I think there will be a lot of space on the device for that purposes. So maybe one more thing there. So I mentioned earlier, so we're in touch with a lot of researchers, and I think some use cases are also that you just have a box and you can put into somebody's apartment to measure air quality for a week, and then you kind of pick it up, you download the data, and you analyze it. So yeah, these are some of the things we want to support there as well.
Will there be any way to like upload routes or upload data from the Go to the AirGradient map?
Yes. So I think I mentioned it earlier. So actually, it's a strong focus for us to really, go from data to action and supporting these community groups with their advocacy events. Also, personal people, obviously, it could be interesting if people take the same routes in their cities and can actually detect these hotspots. Yes, so it's definitely something we will support, and I think that's also something that will be really, really important to drive cleaner air awareness and action in cities basically where people live. Yes, definitely.
Um, was a noise sensor something that we
Yeah.
looked into adding on the Go?
We also looked into this. There's also, but this is all a little bit unconfirmed. So we want to have some extension slot in the Go. And actually, one of the first modules we want to then develop is basically a noise sensor that can measure, the decibels in the city. But this is all, like we need to do the testing, we need to develop this thing. So I would say this is the idea stage at the moment, but I know there's interest from researchers. I just talked today with one at the conference. So it's definitely something we want to look into and then see if we can implement this.
I believe that about sums up the questions that I saw. So maybe if anybody has any final questions, please feel free to put them in the chat or speak up now and we can answer those.
Yeah, maybe one more thing that didn't came up. So we also plan to have a kind of battery extension pack for this device because we know that there are researchers out there that would love to have high frequency multi-day measurements, but then potentially maybe just integrate it into like a backpack where you can have a little bit of more weight or more, kind of bigger units implemented. So this is something that we think could be quite useful for that particular use case. And then I think the extensibility is, I mean, it's something that we stand for as AirGradient, the repairability, also like this modular system. Obviously, there are more limitations in a smaller device, but having at least like one or two extension slots that, potentially with the microphone for noise measurement or other things, I think could be quite helpful.
Just a couple of final questions by the looks of it. Matt asked if the battery can be replaced, if it's a standard form factor, and also if the maximum charge level can be reduced to extend the lifespan.
So for the first one, yeah, at the moment we use, I think a 60-50-60 battery, 3.7 volts with a standard plug. So it will not be soldered in. The cable will really be a plug that people can replace the battery. We might, in order to maximize the battery capacity, we might actually order a kind of more customized form factor, but this does not prevent you from replacing it with maybe just a tiny bit smaller one that you can get in the open market. For the charge levels, I have to talk to the engineers, but I know that we actually at the moment we don't support super fast charging because we don't want to create. I think heat is another issue there, which might then impact the measurements, but also like just extend the battery life. But yeah, this is something I think we have to follow up then with the engineers.
Okay. Unless I've missed something on accident, I believe I've covered most of the questions.
Great. I mean, we are right on the spot, 2 minutes left. Yeah. So thank you very much. I think it was the biggest webinar we had so far, and it's super motivating, I think, for the whole AirGradient team to see that much interest in the new product. I can say personally, I have been very heavily involved in the development. I think it's a great device. I'm really looking forward to get it now into really scaling up the production and having this out. And I think if we and the whole AirGradient team is personally invested in that product, then I think we can also make sure it's really performing well. It's always like, what do you say, like you're dog fooding your own products, basically. Yeah, so thank you very much for participating. And if you have any questions coming up or yeah, like things you want to share with us, then just contact us. I think pretty much everybody knows my email, or you go through our support form on the website, and then we are happy to, yeah, like see how we can help you or share your ideas. Thank you, and have a great day.